Off where we left off. And you might hear some little guitars, ukulele. No, I guess not. She gave up on that. So, um, before we continue, is there any questions for what we just did? So far, we created objects. Actually, a better term would be we instantiated student objects, right? So every time we use the keyword new, this created an instance of that object. This is important. So again, gets created, it gets placed inside the memory, on the heap memory, with the given size it requires. And the given size is usually calculated with all of these in mind, and even the methods as well. Right? So whenever we use that keyword new, we're creating an instance. I'll actually put it here. So new keyword creates an instance of the class. So what this means is, like, even though the class, again, it's a blueprint, the instance is different objects of that blueprint. So like you guys, you're 18 students right now. You're 18 different, but still the same, right? You're still students. You all have the same attributes, the same methods, actions that you could do. But you're all different in your own way. You all have different first name, last name, sex, etc. You all have different, you could vary on how you study. Some of you barely study, some of you study a lot, some of you, you maybe you could even add another one, some of you cheat, right? And then, and who you cheat on? Well, student cheat on this guy, so cheat other students, right? Whatever you do, but you gotta understand that you all have these attributes, you all could do these actions. Some of you might not, some of you might, it doesn't really matter. The point is, you could, you have the potential, you are giving a possibility to that. Okay, so any questions about all of this? No, everyone's good. So a couple things to note. I'm gonna go ahead and erase. Actually, you know what? Let's go ahead and zone that. Refactor, extract method. So let's make that into, again, I'm gonna give you the codes at the end. Let's make that into initial student object. Okay, whatever it is. And again, we're doing that just so I could put it on the side and you still have the code without me changing the code too many times. And as we learn and we adapt and we improve, we will change the code more and more and more often. Right? Actually, before we go further, I want to give you an extra out of topic again. This extra thing is to make you type faster. So as we start typing stuff, and it's not about you typing, this you could learn on your own. It's about navigating words a bit faster. And again, you're already there and you say, well, on my keyboard there's the end and the home, which allows my cursor to go back and forth. But we could do a bit more than that. One of that is to navigate per word. Notice how my cursor is jumping words, right? And to be able to do that, you use the control key, hold down the control key, and then use left and right arrow. And this becomes useful because, well, now I could go and just use my keyboard rather than my mouse all the time. You'll notice that switching from keyboard and mouse, you lose some time and you lose your train of thought. And the better you are at controlling your tools, the better you will retain what you're doing and be more focused and do a better job. So holding down the control allows you to jump words. If you hold down control and you press the backspace button, the button that's right on top of your enter, or at least one or two keys on top of your enter, it allows you to delete the word before the cursor And if you hold down Control and press delete, it allows you to delete the word after the cursor. So if I press delete, das will get deleted. If I press Control delete again, DSCD will get deleted, right? And if I press Control backspace, it will delete the word before, right? Okay, so that's one thing. So the Control key allows us to have power over words, let's say. It does more than that, but power over words. And you could use that in anything, even if it was on a website or whatever. This is built into the OS and not built into any IDE specifically. Another thing you might want to do, I did a lot of copy pasting and whatnot, but let's say I create a new student, let's call it S1 this time, and I'm a bit too lazy to write this whole thing, so let's go ahead and copy all of that. And let's say, oops, we don't need this part anymore. Okay, so let's say I created the student 1 again, and I need this line multiple times. Well, now we don't need to select the line. If we are on the line and we press Control C, it will actually copy the whole line for you, and this is part of the IDE. So now we could just press Control V multiple times, actually. Control C, Control V, and we get all our students. Cool. And now maybe you want to do something more funky with this. So let's say I want to print out all their names. So let's go make this 2, 3, 4, 5. And you want to print out all their names. Well, to print out all their names, well, we need to go through each one of them and type in first name, last name, etc. And then we need to put that in system.out.println. So if you wanted to do that, it becomes a lot of work. So one thing we could do, well, we first need all of these variables, so we need to copy those. So hold down Control, not Control, hold down Alt, and then click and drag, and you'll notice now you could actually select on multiple lines, and this is nice too, right? Again, you could think of it as an array, and it's figuring out things. So I'm going to select all of those, copy that, and then I'm going to go to the next line here, and you'll notice it's going to put it something like this. And this is the auto spacing from the IDE. Now, still using that Alt key, we're going to go at the beginning of S1, hold down Alt, and click and drag until we go down here. And you notice we have a selection, but if we let go, you'll notice now we have more than one cursor, and this could allow us to do some funky stuff. So I'm going to go type in SOUT. If you look at it, it's typing it all at the same time. In this case, again, SOUT, press enter, system.out.println, press delete a couple of times. Now we got our keys in there. Press the right key, go over the end, type in first name, close it, semicolon, right? And again, it's not crazy useful and whatnot, but it is useful and it makes my life easier. And as you learn to use these tools that you're given, like give you another example, if I'm going through your documents and for some reason like here it's too small, and I could just press one shortcut key, makes enough space to show me everything. These are cool things you could have power over. And again, the more you know about your computer, the more power you have over it, the more control you would have over some stuff. This is why I always tell you learn those things rather than just use something without understanding it completely. Anyway, back to topic. And again, I'll add this here and I'll leave it Alt. And this would give you power over cursor. Any questions? All right, let me drink some water and we'll continue there. Okay, so now having that said, having all of this stuff shown, let me draw one more time. So again, when we create the student S1, actually I could do let's try using this tools a bit more. When I create this S1, I get two things. One is the stack. And the other one is the heap memory, right? So when I create S1 over here, at the bottom of my stack, it's gonna create a variable called S1. And somewhere inside the memory, actually let's see what this looks like. Yep, that looks not what I want. And inside the memory, actually that's not bad, we'll just do that. And inside the memory somewhere, it created object student. So this is the new student. So the student object, yeah, is actually somewhere in the memory. And the only thing that we are doing is the only thing that this variable is doing is holding on to this location. So this is an address to where this thing belongs, right? And as we create more students, they're all going to get added to the stack. And again, these are addresses, so they're always consistent on the size that they have. But on the heap memory, the actual object is much bigger, right? And as it gets assigned, they'll all go there. Now, this is a term we already talked about. This objects, just like our string, are something we call immutable objects. Immutable. If you guys remember what immutable means, well, actually, if you guys remember what mutable means, we could take out, or we could create this word mutant from there, from our X-Men and from our mutant friends, whatever you want to call them. Their meaning is that they change, or they could change, and they could vary and change. But all objects, just like string, are immutable, so they cannot change at all. Not possible to change. While this one is possible to change. Well, you're gonna tell me, well, that, oops, what did I do? Let's go back, whatever that was. Sorry, I clicked on the wrong button. So immutable means not possible to change. Well, the mutable, it's possible to change. They're mutants, basically. Think about mutants. Now, you're gonna tell me, well, that doesn't make sense, sir, because S1, even though the first name and the last name has been assigned, I could always go and say S1 first name equals, let's say someone else, let's say Javid. And there's no errors there. And it's gonna change that, the variable, in this case, the string over here, first name. But, sir, you just said not only is objects, in this case this one, immutable, but strings as well is immutable. So how was it possible to change? Well, actually, what happened in there is not that you changed the value, is that you created something new. So let's say if I do something like this, S1 equals another new student. I'm a bit too lazy to do all of this, copy. And in that new object, when we make it equal something else, we're not changing the value, we're actually creating, let me change color here, let's go light blue. We're creating another object, student, another object student, and what we're doing is we're reassigning our arrow here to not go to that one but to go to the next one. So now our arrow is pointing to this one, and this one is gone, so this one is no more. Okay, I'm leaving there for showing that's there. So when we're doing this is why it's immutable, because we're never changing this, and again, it cannot change for the sole fact that over here, right beside it, there might be something, and we would be overlapping onto that memory. There might be your Chrome here, and we cannot overlap in the memory of that location. So that's why we need to create a new one, ask the OS or whoever's taking charge of our memory allocation to give us a new space with the specified space, right? So computers are not that strong. They're not dynamically figuring things out as they go. They just redo things to make it convenient for everyone. And the same thing goes for strings. So over here, if I, let's say over here when I created S1 first name Javid, sorry, if the moment I created Harmanpreet here, well, inside here, let me go on drawing. Inside here, there was a pointer for the first name that went to here. This is FN. And inside here was Harmanpreet, right? And the moment I changed it on line 42, let me change colors. The moment I changed it on line 42, this part, it actually just recreated an object and added Javid. Right? So now this is pointing to that. So again, it's immutable because it's never changing. You cannot change. The only thing that's really mutable is, you know, your primitive types, pretty much. Any questions? And again, this is a big reason why it's immutable is because the size of a string, if you remember, it's a character array. So it could get bigger or smaller. The array is different every time. It's not going to go assign it, let's say if it was all the characters, it would need all the space. It's not going to give you all of the space if you're going to just use 2 letters, right? If you're going to use 2 letters, it's going to go find you enough space to fit your 2 letters. So when you change it, it's going to give you more space or less depending on the value you give it. On the case of students, well, when I do the new keyword, yes, it's going to create me a new object. If I don't, it's not going to create me an object because inside this little box, I have the space for my first name, last name, sex, age, email, etc. Okay, all of it is inside this little box here. Cool? Any questions? Some of them might be pointing outside, but they all fit inside my little box that's there. Any questions? Okay, I'll take a picture of this too. I'll give it to you. Hopefully it makes kind of sense. So the immutable part is something to remember because because it's not mutable, it could give you some concern to look for, but this is not your level that you care for so much, but it's something to remember, and you're going to see a lot of times these two terms coming up. This thing is immutable, this thing is blah blah blah. So that's something. And again, let's go mouse. Let's go ahead and put that inside here. Okay. Next part. So there's that. When you create a object, let's say S2. I'll leave these, I don't care. When you create S2, it actually the default value of any object is null. Right? So this is not the object itself. It's just a container or a variable in the stack that will point to the object when it gets created, when an instance of it gets created. So an instance of it is when we do S2 equals new student, blah, 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 right? And because these are, again, addresses, this is what's so nice, because, again, these are all just containing an address. What we could do is we could make multiple variables point to the same thing. So now I have S2 that's also S1. They're not the same. They're different papers, but on the papers, they have the same address. So again, I should have, well actually let's do a bit and I'll try it in a second. So let's say S2, and let's go ahead and create another student because I'm a bit too lazy. S3 equals S2, right? And now if we go and we do S out and we do S1 first name and we do S2 first name and S3 first name and we run this, what do you think the value is going to be? Well, the value is going to be all the same, right? Well, okay, what if I did that and then I go and do S1 first name equals, let's see who else we have here. We have Jill. S2, we're going to change the first name to, let's see what we have, Niraj. S3, oops. S3, we change it to Parag. Okay, in all three cases, I change it from the initial value, right? So, what should be printed in all these three lines? Can you guys guess? While you're doing the guessing or thinking, I'm gonna go ahead and draw again our stack and our heap memory. And let's go ahead and put that up here. And our heap. Cool. And if you notice, we created three variables. So here we would have our S1. Here we would have our S2. Let me just make it maybe S3. Right? On S1, we did on S1 we did we created a new student object. So somewhere along in the heap, we created an object called, well, an object of type student. And inside that, what happened was this was pointing to that, right? This is done in line, let's say 43. Okay, we're starting from there. Now, line 43, we created S1 and we pointed to S2. We pointed to student. Now, I'm not going to do the rest. What do you think the output is going to be now that I renamed everything? What is going on? Eraser. Sorry, some stuff appeared. What do you think it's going to happen now that I change the value of S1, S2, and S3? Oh, and I think I allow you guys to draw on my screen, by the way. I'm not too sure. But anyway, the point is, what do you guys think is going to happen? What do you think the output is going to be of these three lines? Anyone? Mistakes are okay to do, guys. Not trying is going to be an issue. Or maybe you guys didn't come back from your break. Anyway. We got some people. I can't hear you again. This stupid thing. Give me 1 second. Try talking now. Hello? No, I can't hear you. 1 second. So much problems. You don't think? Okay, now I could hear. Can you say it again, please?
Yes, it's a Jill Neeraj Param.
I didn't understand what that means.
Means it will print Jill Neeraj Param.
Oh, okay. Sorry, I was. All right. So
I think it will only print G 3 times.
So one of you said it's gonna print Jill, Niraj, Param, and another one said it's only gonna print Jill. Do we got any other answers? Well, actually, you're both wrong. So what happens is, well, actually, I want to see if you could get an answer by the time I reach this line. Okay, I'm not gonna run it yet. So what happens is on line 43, we created a new instance of students. So this is the student instance. And S1 became the address that points to that student. On S2, when we created S2, currently it's set to null. So basically it's not pointing to anything. There's no address in there. But the next line over, we said S2 equals the same address as S1. So we notice S1 is pointing to this. So S2 is also gonna be, let's change color. So S2 is also gonna point to this, right? And notice the next thing we did. We created a variable S3 and we said it's also pointing to whatever S2 is pointing. And we notice S2 is currently pointing here. So in this one, we are also pointing to this. So in all three cases, they're referring to the same apartment. In this case, the same student. So if the same student, we change his name, well, it would be changed for all of them, right? So what's happening here, line 49, we say go to the first student, S1. So it's in here, in this thing. And go ahead and change his first name to Gio. So this Gio comes in here, right? So whatever the first name was, now it is Gio inside this instance that we're looking here. Line 50 says, go to where S2 is pointing. Well, S2 is pointing to this instance and change the first name to Niraj, right? And S3 is saying, go to where the instance of student is
Param?
and change the value to Param, yeah. So what's happening is, there's two things that's happening. One, you gotta remember that the computer is stupid, so it could only do one line at a time, from top to bottom. So it does this first, then this, then this. Second thing you need to understand is all three of them are pointing to the same instance, to the same object, to the same student. So I'm gonna change his name to Jill, that's what he does. Then I'm gonna change it to Niraj, then I'm gonna change it to Param. Well, obviously the one that's gonna stay is the last one because that was the last change I did, right? So in the case of when we're printing them, well, we're all accessing the same address 3 times, and we're all accessing the same variable. So in all 3 cases, the student's name is gonna be Param. You guys see that? Because all 3 of them are talking about the same person, right? If I wanted to, just give you guys, let's say after this, and let's say, what is the address, what is the object that these 3 guys are referring to? And if we run it, it should give you the same address. And look at this. So a student object at address this, and they're all having the same address. Does this make sense? So even though we have multiple variables, S1, S2, S3, because it's a big paper that just says where that object actually is, it's not the object itself. And this is important because even though we have 3 variables, it does not mean we have 3 objects. We don't have 3 instances of that object student. Right? I hope this makes sense because we're going to be passing that variable to functions. Maybe multiple objects will have access to that. A good example would be inside our students. Well, we're going to have a course or multiple courses, but that course is going to have a lot of different students. So the same course is going to be inside multiple instances of students. So let's say in this case, we have, let's make it into an array. Let's say at max any students could have is 3 courses, okay? But let's make it easy for us right now. We're gonna make it 2, okay? Just an easy number so I don't have to do much. Now, currently course has nothing in there, okay? And we're not gonna fill it up yet, I'm too lazy. What we're gonna do though, go inside main. we're gonna create one course. So in this case, course, let's say Java 1 equals new course. We're using the default constructor, so basically we're not doing anything. And my computer froze again. Give it 1 second. There we go. So we created a course Java, and let's start a course C++. We can't add symbols in there. Let's do plus plus equals new course. Right? And let's do a few more things. And inside each courses, a course has a lot of students, right? So composition again. In this case, we're gonna add a students array, and this is all the students that belong inside this course. So we're gonna initialize it here, and let's say at maximum any course should only have at max really only each course should only have like 10 to 15 students, but you know how schools are, they're gonna go and put in 40 students in a class. But yes.
So basically, stack is working on LIFO kind of thing. Last in, first out.
It has nothing to do with last in, first out. This is just a stack. This is the way that they added the stuff. The last in, first out, it works, it does do it, but only for functions. And when we get more into stacks, we could talk about that. But for now, this is just how it's set up. And it's nothing to do with first in, first out, to be honest. At least not yet. At least for us, it doesn't matter. How about that?
Okay, sir.
And again, take everything with a grain of salt. You'll see the definition of something might change as your knowledge grows or your experience adds up. It's just not to get too confusing with anything. You don't need to think too much about the stack. Just remember that this is where any constant values are stored. In this case, primitive types, your addresses of all the objects are going to be here, the references, whatever they call it. And the heap is where it's the memory is. Every other stuff is in there. It could be big, small, whatever, it will be here. So inside course, we got students. So now looks what's interesting. So let's say, I didn't want to change this too much. Okay, you know what? We're going to do this, we're going to bring in the second step, okay? Let's go ahead and put this inside a new one. Refactor, extract methods. And we're going to call this one same pointers, okay? They're all pointing to the same thing. And actually, did I take a picture? Let me take a picture first. I think it was a useful thing. Yeah, let me grab a picture. There we go. Okay, so all of this points to the same thing. Refactor, extract methods, and same pointers. Okay, let's go back to here. When I create that student one, I'm going to comment this one out. We don't need it right now. And we're going to create a few more students, okay? I'm a bit too lazy to create too much. Notice I'm always going to say I'm lazy and whatnot, and you'll see me doing 100 times more work. But whenever I say I'm lazy, it's mostly saying I am lazy, one thing. Second thing, it's basically I want to do the job right once, right? And repetition stuff doesn't add anything to my job. Anyway, doesn't matter. Moving on. So now we have 3 students, right? And they're 3 different ones. We have Harmanpreet, Abid, and let's create another one. We were with Javid. We're gonna have these 3 students. Now, we said we're gonna create some courses. Course Java 1, new course, and course C++. Course new course. Right? And if we look inside course right now, it doesn't have anything because we didn't fill it up, but it has a amount of students. So now these references, this is what's going to be really interesting. And we're going to redraw this in a second. Actually, let's go ahead and, let's go ahead and erase S2 and, oops. S2 and S3, we're going to add it. Right? S2 and S3, we have them, but they're a new instance, right? So they're not the same object anymore. So in this case, we have, let me just draw a couple things. So let's say it's somewhere else in the memory, we don't know, and this one is also somewhere else. Let's do a different color so we don't mistake it. Okay, so this S2 is pointing to here, and these colors are getting bad. And this S3 is pointing to this, and all three of them are also, as we said, students. Cool. So 3 objects got created, and then we also created 2 other objects. One of them, it was Java 1, and the other one was C++. Okay, and mind you, it's a bit ugly how I did it, but it's fine, it works out. Okay, and let's say again, let's say now we have the course 1 here and the course 2 here, okay? And again, let's do a little arrow. Let's change the color actually. Let's make this one red. So Java 1, let's say it goes here, okay? And I'm gonna probably ignore the C++. And let's say the C++ also goes here. Cool? So now we have 3 instances of student, and we have 2 instances of course. So far so good, right? This is these lines I see here, these 5 lines. Now, what's interesting is now that I have all of this, we could assign my students to different courses. So S1 dot, let's say he goes to courses. We're gonna say because again, we created the objects inside this, right? So if we look here, courses has already been created. Okay, I'm not gonna show it here, but let's say courses at the first position, I'm gonna make it equal to Java 1. S student 1 courses at position 1 is gonna equal C++. So now we know Harmanpreet currently has Java 1 and C++ as his courses, right? Because these are references. So the object course is still the same one. It's not going to change, but now we notice that there is 2 new arrows. 2 new arrows that say this. So S1 is Harmanpreet. One of those arrows is pointing here, and the other arrow is pointing here. Everyone with me? And let's say Abin, he's taking only Java, right? So position 0, only Java. And the other position by default is going to be null, right? The default value of a object is null. And let's say Javid is going to take no courses because, you know, he's lazy or something. Right? Does that make sense? Now, let's talk about the Java. Again, they have students as well. So Java has the first student, which is Harmanpreet. Java also has another student, which is, where is it? Abid, S2. Right? C++, on the other hand, only has one student. And that is, where is it? S2, which is Abid. So now you could see there's a lot of references going back and forth, and it could be hundreds. If you want to, we could do some funky stuff. Let's just print out a bit, okay? Let's do a bit of funky stuff. So let's say, Harmanpreet, what is your first class? Sorry, this is not first class. Courses at position 0, right? And actually, let's add some stuff inside the courses. Let's make it a bit more useful here. Let's say string name. Again, we'll add it, create a constructor, course, and inside here we have string, and pretty much that's it, okay? With too lazy. Okay, so we say, Harmanpreet, what's your first course? Well, he says this. And then I ask the same question to Abin. And then I ask the same question to Java. Okay, and you'll notice courses here is messing up. So here, this is the course Java. And over here is the course C++. And if I do this, if you think about it, what do you think is going to output in each one of these lines? Well, the first one, it's easy. So we go S1, go to my variable courses, at position 0. Notice at position 0, we set it
Java 1.
Yeah. So this one is going to give us Java 1. Or it's going to give us Java, actually. This is the box's name, the variable name. This is the actual name, the attribute's name inside the course. The second one, it's going to again be S2. We notice S2, we give a value, and it's Java again. So this one is going to be Java. S3, on the other hand, never did we define anything for courses. So courses over here, by default value, it would be null. And because we're trying to access something that's null, this is going to throw us an error. And we'll talk about errors in a bit. Or maybe next week, we'll see how it goes. So if I run this application, you'll notice the two first values, and the last one is a big error. Java, Java, and null pointer exception. Basically saying we try to access something that doesn't exist. Any questions?
Sir, can you explain once again what happens exactly when S1 dot course and then again dot name? I'm confused right over there.
So S1, we're saying go inside the object of S1. We're dereferencing. We're going to this object over here. I don't know if you guys are seeing my mouse.
Yes, I can see, sir.
Okay, so currently we're here. And that's what S1 does. From S1, we say grab the attribute course. So inside the student object, we're grabbing the attribute course 0. That course 0 is again a reference to a course. So from here, we're jumping to here. Right? To this course, which is, I don't remember, actually no, Java 1 is here, sorry. We're jumping to here. Right? And then we're saying inside that, go grab the attribute name. In this case, name isn't a object. Well, actually it is, it's a string, but let's say inside the attribute string, we have the value of course, which is Java. Right? Does that make sense?
Okay, so yeah, got it. Thank
So
you.
from this arrow, we're going to student. From this, we're grabbing courses at position 0, which is here. And from here, we're grabbing the name. And this is what's so funky, is because of all these references, we could do something really neat. So again, this is an error. I'm going to just comment it out so I could do other stuff. Let's say, now you're going to see this is fun. Because all of these are references to each other, we could actually go into this thing, which I like to call a big circle. So remember that courses also has an array of students, right? And we set it up right here. So courses at position, let's say 1, go at to students, we're at the student, go at, let's say, what's his first name? Let's see if you guys could figure out what's the first name here. So from the student 1, I went to his first course, and then I went to student 1. From that course, who's the second student, because position 1 is actually the second position. And from that, I asked what's the first name. And if we do the same thing, and I say s1.courses at position 0 dot students, let's say at position 0 dot first name. Which one is this guy? And if we go a bit further, we could even make it more complicated. Student 1, let's see what we have here. Student 2, okay, he has one course. And from that one...
Excuse me, sir.
Yes, sir.
So in short, we are actually jumping from class to class.
From object to object.
Yeah, I mean, yeah, object to object. So, okay.
Exactly. Because all of these are just a pointer to something else. They're referencing something else. Let's make it more complicated. I'm losing myself as I'm typing this. It's a bit fun. Sometimes you do something stupid and you get some fun out of it, right? Actually, I'll keep this one for last. And let's make something even more funky than ever. Let's see if you guys could figure this out. Yeah. My only comment on this is lol. So, see if you guys could figure out what these 3 outputs are gonna be. These 5 outputs gonna be. And again, we have 3 students. Student 3 is not taking any courses. Javid, I don't know what you're doing. You should take some courses. But he's not. And we have 2 course objects. Notice what we assign. And notice that these are all just big pointers. Just one referencing the other one. Alright, did you guys have an idea? So, line 60, what is it outputting?
Abin.
Harman, okay. Harman, please. So
Abin.
Abin.
Abin, okay, sorry.
Abin.
My bad. Abin?
Abin, yeah.
Okay. So, we check it out. S1, we're going to the student object. From the student object, from this part, we're going to course 0. Course 0 was Java 1.
Java.
So we go to Java 1, and then we ask from Java 1, who's your second student? Right? Not position 0, position 1. So if you look at Java 1 over here, we have position 2 is S2. And S2 is this guy. So we come down to here, and we ask the S2 guy, who is your first name? And we get Abid. Good job. Very well done. Let's get more funky. And again, we do the same thing. So we go to S1. From this, we go to the first course. From the first course, we go to the first student. And that would be, again, S1.
Harmanpreet.
Harmanpreet, yes. Okay. So you guys are getting the hang of it. Okay, fine. The second one. This time we're starting out with student number 2, which is Abid. We say, go to your first course, which again, it's Java 1. Made it a bit too easy. From Java 1, go to your second student and get his first name. Who's that going to be? Abin as well. Good job. Now let's get some funkiness going on. From this first student, get the first course. From the first course, get the first student. From the first student, get the second course. From the second course, get the first student. From the first student, get the second course, and give me that name. What do you guys think it is? So again, let's start it out. So S1, so we're at Harmanpreet right now. Go to first course. The first course is Java. From the first course, give me the first student. The first student of Java is S1. So we're back to Harmanpreet. From Harmanpreet, give me the second course. And if we look over here, the second course is C++. From C++, give me the first student, which is S2, which is Abid. So even though, so this is a bit funky, even though Abid never registered C++ as his course, C++ did. So you see the a bit of a mind trick here. So even though Abin does not have the course C++, C++ has the student Abin. So this was like a administrator error, you could say, right? Does that make sense? So from here, when we're accessing the first student inside the C++ course, it's actually Abin who doesn't have that course, which is fine. So now we're at Abin's object, right? S2. And we ask Abin, what are the courses you have? And Abin says, well, I only have one course, which is Java 1. But in this case, we're trying to access the second course, so this should throw us a error. If I change this to 0, well then now it should be fine, and it would say Java 1. Right? Well, it should say Java, not Java 1. And then this one, we start again. Well, this time we start with Abin, and we say go to course 1, which is...
He doesn't have.
And again, so this would be an error. You're trying to access something that's null. You could print out null, but you can't access something that's null. Okay? And let's run this. So let's check out our answers. I don't know if you could see correctly. Here we go. So we have, actually we have this. Okay, so there's a few things. The Java we're gonna ignore, okay? From here, Abin, we got Abin. Good job. Harmanpreet, Abin. And notice over here it's Java because we fixed the error. But over here, we're trying to access something that does not exist. And again, we'll get this error called null pointer exception. Cool? Any questions, guys? And again, I'll take a picture, give it to you guys at the end. But this is the stuff that you need to understand. And this is the part that I see a lot of my students, even though they passed OOP course and all of those, for some reason they never understood it, and they always make the same mistake. Okay, so this is a lot of circular stuff, but you got to remember that all of these are just pointers or references or addresses of where the other object exists, and we're going to go in circles for hours and whatnot. Cool. So in this case, they're doing something called a shared reference. So both of them are pointing to the same thing. And this is important because as you guys are 17 different students, you only have one teacher, right? Well, at least right now. And that teacher is me. And let's say for any reason, I don't teach. Well, none of you would be able to learn because I'm not teaching. Well, let's say you have to learn from the teacher. If I don't give out the grades, well, none of you would get the grades, right? You're all expecting results from one entity, from one instance, and that instance would be the teacher, which is me. There's a lot of teachers at our school, but it doesn't mean they matter to you. Those teachers are kind of, who is that person? I never had it. He's not my teacher. I don't really care. Right? And it's the same thing that's going on inside the heap memory. It's all of these things that are pointing to each other, and they could do various shenanigans, let's say. And this is important because we don't want to redefine something that already exists. And we don't want to have 5 objects all around because we have 5 different variable names. Cool? Any questions? Because from here on out, you're gonna see we're reaching the end of our foundation, which is, we learned the basics, and now we're touching OOP, and this is the OOP part. And as soon as we finish OOP, you have your foundation. So it's important that you ask the questions before we reach the complete end, because then there's too much stuff on top of each other for it to make sense if you didn't understand something beforehand.
Hello, sir.
Yes.
Now if we change the student S1 to S2 and then it allocate to S2 to S3 and
Can you tell me which line number?
no, not this not in this program.
Okay.
If we do stuff we did in the past, S1 is equal to S2, S2 is equal to S3, and then S3 is equal to S1, then what will happen?
Okay, well, let's do it here. That's a great question. So over here, rather than creating these students, I'm going to make it equal to S1. And over here, I'm going to make it equal to S3. Okay? Sorry, S2. Now, very good question. Who was that? That was Ridam. Ridam, very good question. Now, I want you to redo these things and tell me what would be the output on the screen. Is it the same thing? Is it different? Is there a mistake somewhere? And you see there's a lot of warnings that's popping up. These yellow highlights are warnings from the IDE telling me, hey, are you sure there's something going on here? And again, I'm gonna redraw this in a second. I already took a picture. Let's go ahead and use the eraser. So S1 is this one, but S2 we don't need that. S3, oops, wrong. We don't need that. And we can go ahead and erase this. So we have. So let's do it. I don't know if you guys figured it out. Anyone figured out what's the first line 56? What's the output? The new one? Okay. So this one is pretty easy. S1 to course 0, give me name. Okay, actually we'll do all of them. So starting at line 40. We create S1, a variable, that's this. And we create we instantiate that variable. We instantiate the student object and we appoint to it. So it goes to here. S2 on the other hand, let me grab my drawing pin. S2 on the other hand, we're making it equal to where S1 is pointing. So these two are both pointers to location. So S2 is also going to point to this location. And S3 is going to point to the same location as S2. Let me change the color, make it fancy. So now all three of our students are actually the same student. Cool? Java 1, C++, same thing. We created two different courses. Now, student 1, which they're the same one, we're setting the first course to Java 1. So the first course over here, we're going to set it by the color pink, let's say. We're going to set it to Java 1. That's the first one. Actually, let's go ahead and make some text here. I'm going to make some 0 and 1. Okay, so actually, let's put this course 0 and course 1, so it's not too confusing. So here, what we said was, oops, here we go. So here, what we said was, one second, course 0 is pointing to Java 1. So this is line 47. Line 48, we say course 1 is pointing to C++. So now it's like this. So far, so good? Now, line 50, we're saying for student number 2, which in this case is the same student, set the course 0, set it to Java. Well, it's already set to Java, and that's basically what the error is. So if I put my mouse over it, variable is already assigned to this value. So it's the same value I'm assigning here and here. It's the same exact thing. So this little pink line is still good. Line 52 though says Java 1 students at position 0 equals student 1. So inside my course here, inside my Java course, student at position 0 is going to point to S1, and S1 is pointing to this one. So let's change the color to, I don't know, light blue. So the student in one here is pointing to here, right? And then we say student number one is pointing to student two. Well, student two is still, again, this one. So this one is also pointing to here, right? That's line 53. And line 54 says C++ student 0 is pointing to student 2, which is also this object. So all of them are referencing to the same thing. Right? So now we have, if you look at the arrows, we have 5 references to student, which is all the same student. Okay. So let's go down. Now that we did from line 40 to line 54, if we look at this line, line 56, we're saying student 1. Who's student 1? Is this guy. Go give me your first course. Your first course is Java, so this stays the same. Student 2, who is it? Well, it's the same guy. We're talking about the same person. His name might be Joe, his name might be whatever, but it's always the same guy. We're always talking with the same person, right? You could call me teacher, Reza, Rez, or whoever, whatever name you have for me, but we're always talking about the teacher, which is me, which is the same person, right? You could call me that asshole, that jackass, that great teacher, that amazing teacher, the worst teacher, but it's all synonyms to representing the same person. And this is what it is coming down to here. All of these S1, S2, and S3 are synonyms of the same object, which is the student. So S2, we're saying, what is your first course? And again, it's going to say Java. And this time, if we uncomment this, we'll notice S3 is also pointing to student. And we say what your course is. Well, again, at position 0 is still Java. Ridam, is that, does that make sense? Do we agree, everyone? Anyone doesn't agree, actually? Okay, let's get to the more funky stuff. Now we're saying the first student, give me his first course, give me the second student in there, and give me his first name. So the first student is this guy. Get his first course, it's this guy, the Java. Get the second student, and if we look over here, it's pointing to S2, and S2 is pointing to the same student. And give me his first name. So his first name is going to be Harmanpreet. Do the line 61. Stop me if you want me to redo something. Give me the first student, again, this one. Give me his first course, again, Java. From that first course, give me the first student, again, Harmanpreet. And that's Harmanpreet. And in the case of all of them, you'll notice it's always gonna be Harmanpreet. Right? What about this one? So from the first student, go to the first course, that's Java. Go to the first student, which is him again. Go to the second course. Ooh, go to the second course. And then go to the first student, and then go to the first course, and then to get the name. And again, it's going to be Java. And S2 over here points to this student. Go to the second course. Go to the second student. Right, second student. It's still going to point to here. And get the first name, and in this case, is going to be Harmanpreet. And as always, I tried it out. I got me some values. And now I'm going to make sure that that value matches what I thought. If you always just let it run and never try it out yourself, you're always going to, say, yeah, that's what I thought. That's what I thought. Okay, it's always good to test out. So if we notice, we got all 3 Javas. Then we got all 3 Harmanpreets. Then we got Java, and this one is giving us an error. Ooh, what happened? Let's check that out. So, S2, it's the same object. Give me course 1. Then we set S2, course 1 is set over here. This is the same object, right? So this or this is the same thing. So we set the course 1 to C++. So we're at C++. Give me the student. This is the problem. Give me the student at the second position. If you notice, C++, we only set the student at the first position and never at the second. So the default value of an object is null. So in this case, this points out to nothing. And then we try to get the name, so this gives us an error. See, I made a mistake. And this is why we do this. We test it out, think about something, and question things like Redam did there. Say, what would happen if all of them were the same object? Well, this would happen. And we could have done the same thing with courses, and this error would go away. If we would have said, well, this one is also Java 1, well, there we go. But now we don't have the course C++, now it's just a big mess. So let's run it, and you'll see the error is going to go away. And now, I'm missing a semicolon. So, oops, run, press run, and look at that. It's all Javas because there's no other courses, and there's no errors. Cool. Any questions? It's not bad. This was pretty fun. That was a great question, actually. That was the first time I heard that question. I'll actually start bringing that up. That was pretty nice. Hey guys, this is really important. So if you have a question, this is the moment. All right. So let's go ahead and make this even more complicated. So the first thing we're gonna do is we're gonna undo all of this. Okay. And I think I took a screenshot, but I'll do it again. I'll send you everything. You'll be fine. And let's clear all of the drawings, and let's go and shove this somewhere else. What am I doing? Refactor, extract method. Pointers or reference in circles. Reference in circles, right? And we'll comment it out. Cool. So back to student over here. Whew, that was big stuff. I think we got the initial idea of objects done. I am wondering. I'm just thinking about what's the next thing I want to go through with you guys, and we'll go from there. By the way, this action methods, verbs, you could also talk about it as instance methods, right? Instant methods. Okay. Yeah. Okay. Kinda, I think I want to take a little. Okay, it's already pretty late. So let me just do a quick review. Okay, actually, well, there's something I still want to do before we leave the rest for the next course. So let's go back to our main, and this is gonna be an important part. So again, we want to create student, and I'm gonna create that. And this time I'm gonna name him Redam because I got impressed. All right, and we can put a lot of spaces so we clear out our screen. Okay, in the case of Redam, when I created the object Redam, notice right now there's something I'm missing from all of my attributes and my functions. And that's the optional key here called accessor. So there's an optional thing I could have here, which is the accessor. It's if I want to, I do it. If I do not, it will do it by itself. So an accessor is something important. And you'll notice that we have one here, okay? Accessor basically says the access right to that object attributes, I don't know, method, whatever you want to call it. It tells you who has the right to use that or access that or call it or whatever you want to call it. There's three types of accessors that you guys know of. Can you tell me which ones you know?
Public, private,
Public, private, protected.
Public,
Public,
private,
private,
protected.
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 And inside Java, there's actually another one called package, and we're gonna come back to this one. Okay, this one we'll leave it for later. So public, in the case of anything that's set to public, it's accessible to anyone. Everyone and anyone has access to this. And anyone has access to this. So basically, uh, anyone that knows that object exists will be available to come and do something to that object. Modify it, call it, change it, read it, whatever you want to call it. Private is only accessible by the object itself. So whoever owns it, he's the owner and no one else. No one else can even see it. Right? So this is private, not accessible by anyone else other than the object. And protected and package, will come back to this later, okay? So this is for later. Now these two are important. If we look at students, we don't, first of all, we never want to use anything default. So the fact that we did not put an accessor here is automatically wrong, okay? As a beginner, as a junior level, as an entry level, you should never not have it there. And even in a senior level, you wouldn't. Why? Because then you're relying on defaults, on something you have no control on. And not having control is one of the bad things about programming. So here we want to always mention what the accessors should be. Okay? So who has the power to who has the power for these things? Who could see them? Who could change them? And again, if you guys want to know what the default is, actually, do you guys know what the default is in Java?
Private.
Nope. In Java, the default
Protected.
is package. In C++, the default is. So the point is, depending on the language, this private, public, protected package, who decided what becomes the default is the architect who made that language. So you don't want to rely on that, right? So we don't want to rely on Java to figure out, hey, was this the default? And again, you got to remember that when you go work somewhere, you're not going to just use one language. Most of the times you're going to use at least 5 or 6. Based on what you need from that language, you're going to use it and intermingle with other stuff. Okay? So this is not good to rely on the default. Now, forgetting about protected and package, we'll come back to those later on. We have public, which is accessible to everyone, and we have private. So let's think about it. Our student, his ID should be public or private?
Private.
Well, okay, if we make it private, right, we put the accessor. If we make it private, now outside here, actually let's do a quick thing here, S1, I cannot print his ID. And you'll notice if I put my mouse over it, it says ID has a private access in student. So I'm not allowed to come access it here. Private means only inside the class, only inside the object we have access to it. Only inside the class. Right? So here, I want to print out the student, but I have no access to the ID. Does that make sense? Now, why did you want ID to be private?
Simply. Not sure actually.
So that no one changes it.
So that no one changes. That's a perfect answer. However, we're already doing that. How are we already making it so no one else could change it?
By making it final.
Exactly, because it's already final, no one else could change the value. So this, if we leave it public, well, it's finalized. No one can change the value, so it doesn't matter. So over here, they could read the value, so they could see what your student ID is, but they could never say s1.id equals 23. See, it will always give me an error. So in this case, because it's final, we made the variable seeable but not changeable, and this is good. So it's kind of like a semi-private because of the final. You could see it, but you cannot change it. Cool. Now, this next ID, should it be public? Should it be private? What should it be? By the way, does the ID make sense? Why we kept it as a public? So we want people to be able to see his ID, but we don't want him to be able to change, right? So I want to print out this whole student thing. I want to see his ID, but I don't want to be able to change his value. This is why we left it public, but because it's final, the moment I set it in the constructor, it cannot be changed anymore. So this is perfectly fine. Now, next ID. Remember, we use the static shared variable between, well, it's part of the class, part of all students. We made it shared so that we could increment the value every time. Do we want this to be public or do we want it to be private?
Private.
Why private?
So because we don't want anyone to use this instead of except the constructor itself.
Exactly.
I don't want to use this in main.
Yeah, we don't want it to be used outside of student. So inside main, if I wanted to, I could say student dot next ID equals, well, this is the same as me assigning the next ID. This is something wrong. We want this to be automatic. We want this to not be controlled by anyone. So having it public, or in this case, the default package, allows others to modify it. So here, we want that to be private. And because it's not final, it's no good to leave it public, right? And in this case, we don't need outsiders to even know about the next ID. They have no business, no reason for that, right? We've got to think about our design. And in this case, next ID has no purpose of being seen by others. Now, first name, public or private?
Public.
Public. Who was that?
Sir, actually in OOP, which I studied in India, sir, it's a concept called encapsulation.
Okay.
Sir, it states that the attributes of class should be made private and it only can be accessible by its methods.
And why is that?
So I don't know, the teacher like told us like that the attributes of the class can only be accessed by the methods of the class, not directly from the main.
Well, Harmanpreet, I'm gonna say your teacher was bad. One thing. Secondly, the biggest problem is you learned it halfway. And this is something I learned in my whole life, is when you learn something partially, you're worse than someone that didn't learn it at all. Okay? And I'm not saying you were bad here. I'm just saying if you learn something without understanding the reason behind it, you're never going to fully utilize it correctly. Okay?
Yeah.
So you're going to see why what he said was correct and at the same time incorrect. The incorrect part is because he never explained why we needed to do this. If you notice over here, there was no reason for us to create a function called a function to get this ID. And I'm going to explain those as we go down, right? And again, we don't need a function because even though this ID is public, no one else could change it, right? Because of the final. So there's no reason to create an extra layer for doing nothing really. So let's go back to this first name, and you're gonna see we're gonna come back to what he kind of said, but he just didn't explain it, and probably didn't understand it really. The first name, I think it was, who said to make it public?
Rhythm.
Ah,
Me.
Ridam. Perfect. Ridam, this is you. S1 is you, right? And we got your ID, and I printed that out. Now I'm also gonna print out your name, first name, right? Perfectly fine, right, Ridam?
Yes, sir.
And if we run this application right now, let's run it quickly. We should see your ID and Ridam, your first ID and Ridam. Perfect. But Ridam, from today on, I'm gonna rename you to Joe. And you know what? Because I have the power, I'm also gonna rename you inside the Zoom to Joe. And look at your name. If you look inside participants, your name has become Joe. So from now on, your name is Joe. And if you look inside this and I run it, your name is also going to show Joe. Do you know why, Ridam? Or actually, sorry, do you know why Joe?
Yes, sir. Because it's changes from the main that the admin have the right to change the name.
No. This is not why. Admins shouldn't have the power. You should always remember when you're creating objects and whatnot, you're not creating for a specific group of users yet, at least not yet. You're creating for everyone that's going to access your student class. And the only people that are going to access your student class is other programmers, other people working on the same project as yours. So when you're defining these public and private, it's not for the people that are going to be the users of your program, but it's going to be for the developers of your program to make sure that they don't modify what you had intended this class to be for. And the problem wasn't because they're administrators or whatnot. The problem is because your first name is set to public. It's set to be accessed and used by anyone that has it, right? If I made your wallet or your bank account into public, well, the first thing I would do, I don't know about other people, is to go and grab all the money in there and put it in my own pocket, right? So this is the problem with public. It allows other people to modify it when they shouldn't. And in the case of ID, we had final for that. But in the case of first name, we're not going to finalize your name. Maybe someday you do want to change your name to Joe. And you're welcome to do it. You go to the court, you fill out a paper, and it's done. Right?
Hello.
Yes.
So exactly this is what I was talking about.
Exactly.
Like to make
That's
it
where we're
private.
getting
Yep.
to. So that's where we're getting to. As Harmanpreet's teacher said at some point, we want to kind of encapsulate the data where we can't change it, but we could see it. So the first thing I'm going to do first is to change Joe back to... Uh-oh. I lost my control paste. You want to bring back your name to correct? You could just press more and rename yourself. So let's go back to here. So the thing is, we want to be able to get the name, but we don't want to be able to set the name. And again, these are verbs, right? So when we got a verb, we're creating something called a method, an action, something that we could do. And in this case, this thing is called getters and setters. So we want this to be private. We don't want anyone else to change my first name after it's been set. Well, I don't want anyone else other than myself to change the first name. But I want other people to know what my name is. I want you guys to know that my name is Reza. Otherwise, how would you call me, right? So we want to create two functions that will enable us to get this first name. This is called getters and setters. This is also called encapsulation, whatever you want to call it. But encapsulation kind of has some other things into it, but we're going to come back to this. So for now, I'll leave it be because you said it. But in this case, we're really talking about getters and setters. Okay, and they're not really anything crazy. We're just creating a function to help us manage first name. So in this case, I want this to be private, our first name, but I want outsiders to be able to see it. So I'm going to create a public where it returns a string, and we get the first name. And you can see the IntelliSense already knows you're creating a getter. And inside this, I don't need any parameters to function correctly. The only thing I'm going to need is to return the first name. And you got to remember that this, when it gives it back, it's going to give back a copy. So whatever it gets back, it can't really change or do anything funky to it. He has his own copy. So over here, you'll notice I'm getting an error when I'm trying to change Redam's name to Joe. Right? Right, Redam? So when I try to change his name to Joe, I can't do it because I don't have access to it. But I could do s1.getFirstName, which is a public function, which gives me his first name. So let's comment this out. So now I'm creating partial access. Okay, I have to go change all of that. Okay, fine. Let's do that. Give me 1 second, because all the previous code that we had, it's giving me errors for those because first name now is private. Let's see if we could control find and replace. Okay, I'm a bit too lazy. Get first name, and we're gonna just copy this. So this should work. Here, this is gonna give us errors. I'm gonna comment it out. Comment it out. And you could all see that we have no more reds here, so we're good. We have a lot of warnings, but we'll come back to that later. Okay, so now if we run it again, run, we see read band showing. We could get the value, but we cannot change it. Well, sir, can I change the value from what I get? Well, if we do something like this, get first name, this, even though it gives back our value, it's not something we could change. Okay? If I store the value into something, so let's say temp, as an example, and I get the value, well, if I print that value, we'll see it's gonna print readman. And if I change temp to, let's say Joe again, it's gonna change that value to Joe, but you'll notice S1 get first name is still gonna be the same, right? Actually, this is still readman, but then I change it to Joe. This is what it's printing here, line 46, and then readman back to here. Because again, this is sending back a type of copy, you could say. That new copy, we're storing it out. Right? Does this make sense to everyone? So in here, we're giving partial access by creating this getter. Now, something I see a lot of people making mistakes is they make it private. So let's go with last name here. Again, last name, you have a last name, but you don't want others to change your last name. So what they do is they go and make this private, but, so now it's not accessible outside. So let me erase all of this. Where are we? So now system, well, let's say s1 dot last name is not accessible outside. We can't see it here, right? We could, however, print it. Actually, we still can't because I didn't create a getter. So this is not accessible outside, but they come in and they create two getters. Well, they create one getter, get last name. And they create a setter, so they're setting a value. Again, verbs, actions, public, it's void, it's not gonna return anything. Set last name, string last name, and they do something like this. And this is a mistake I see all the time. What is the point of having a getter in the setter, which is public, for something you made private. This is the same as saying, well, that last name, well, it's just the same as saying it should have been just public from the start. Right? We made it private so no one could change the value. But in the setter, this function that we created here, because the only one that could change the values inside the class, and we are inside the class now. But with this function, we're changing the value to anything. So now outsiders, public, outsiders could still change my name. So here we could say s1 dot set last name to Joe. And if we print out his name, s1 dot get last name, we'll notice that it's printing out Joe. Man, I gotta go change all of those. Last name. Give me a second. Again, there we go. Oops, there we go. Where it was, scroll up here. So now his name should have been, last name should have been Apple, but now it's Readman Joe, right? Because even though we created an encapsulation, we created a information hiding, right? We hid the information of his last name. We still went and gave a public setter. And this is not good in this case. We don't need that, right? So this is a mistake. Does this make sense to everyone? Why we shouldn't have both of these public?
So where exactly are getters and setters used then?
Well, it's so getters and setters, it's our own functions. It's just like study, take exam, submit, pay school, cheat. Okay? It's just, there's been so much getters and setters that it became its thing, but it's nothing special. The only thing we're doing with this is we're enforcing or hiding some information. So in this case, first name and last name, right? You all have first names and last name. I have a first name and last name. I want the public to know about this first name, last name. So I tell you guys, hi, my name is Reza. But I don't want you to have access to my first name, last name. I don't want you to change the value of my attributes, right? To do this, I make these private, the attributes, and I create you one getter. In the case,
Okay, so setter is not at all required for this case, right?
Exactly. The mistake I see is you guys put getters and setters without understanding if I need it or not, even though we don't need a setter for, in this case, the last name. Right?
Yeah, okay, sir. Thank you.
Sorry, I'm about to sneeze here. So it's good to have a getter for first name and last name, and you could probably see it's probably would tell you a warning, hey, are you sure you want to do that? You have a getter and a sorry, 1 second. It's telling you, do you really want to have a getter and a setter, which is going against what you're trying to do, which is to privatize it, right? And that, again, for now, we're not going to have both, but eventually we're going to have both. It's just, you got to understand that we're just creating this getter so that others could see our first name, but they cannot change it. So there's no reason to have a setter. Let's go next one. Any other questions? I'm going to go through all this, so we're going to understand this accessor more as we go on. And again, we want to we're down to the sex. Do you want that to be public or do we want that to be private?
Private, sir.
Private. We don't want people to change their sex. Sometimes someone might kick you in the balls and you might change sex. But that's not really what we want, right? Do we want people to know about our sex? Again, this is really your choice, but in this case, you don't go around saying, hey, I'm male, I'm this or that. So this, we could, leave it private, and we don't need a getter or a setter for this. right? Age. Do we want the public to change your age or to know your age? Well, we could allow them to see it, but again, we don't want them to change it. Okay, and we could create a getter for that. I'm going to show you a different way to creating getters. You could right click on this, refactor, encapsulate the fields, and we selected age, and we just want a getter. And we're going to refactor. And the moment I do this, you'll notice age is going to be popping up down here. I'm just going to put it beside everything else. All right, so this is cool if you want to create getters and setters fast. Again, using your IDE for a lot of power is good. Next, email. Do we want that private or public?
Private.
Private. Again, these are personal stuff, right? Address as well. Courses. Now in this case, course or dues is mostly set by, well, actually, let's forget dues for now. Let's leave that private. It's your problem. The courses, though, it's set by the administration, right? So we could allow you to set it yourself. There's multiple ways we could have went at this. I'm just going to show you, what if I wanted to be able to access it myself? And there's a lot of issues here. Actually, I'm wondering if I should set this for another day.
Another day, sir.
Okay, it's fine. We're just gonna do one last thing though before we call it a day, because to be honest, we're already behind. We should have never done any reviews of OOP. This is stuff you should know, right? So hopefully I'm gonna give you work through the week. You need to work at home. I'm telling you, I usually get 4 or 5 failures, and a couple reasons is, one, OOP is misunderstood or not understood at all. Secondly is you don't do anything at home expecting to pass. And again, the goal shouldn't be for passing the school. If you notice, your grades don't mean nothing. And all the schools you went to, how many of those grades came back in your face and said, oh, because you're low or because of this, you got that? The grade is meaningless. What's useful is knowledge. Okay? Anyway, so one last thing I wanted to do is like to show you why we would have a setter. Let's say this age, okay? For some random reason, let's say it's public. Well, let's say it's private. However, I'm going to create another thing. Actually, I already have the getter, so let's go ahead and create the setter. Public void set age. Let's say I allow other people to set my age. But in this case, I don't want the value of age to be any weird numbers. And weird numbers would be less than 0 or over 100. And I think the oldest person is 130. 120. So in this case, when someone sends me a new value for my age, I make a little check. Is age less than 0? Actually, let's do another one. Actually, better than age would be your dues. Okay? Let's say, let me create this right away quickly, encapsulate, getters and access. So let's say people have the right to see your dues, and people are allowed to change it, okay? It's not the correct thing to do, but we're gonna allow people to do it, right? So they could get your dues, and they could set their dues. And again, if we're making both public, we're going against the reason of making this private. There was no point of making this private if both of them are gonna be public. But this is where encapsulation comes in. What I want to do is to enforce that the values of dues are gonna be within a specific number. So dues is something that the student owes as money. So dues cannot ever be, let's say, negative. So if dues is not, let's say, if it's dues is not, so if let's say if it's less than 0, I want to return. Return ends the function, right? Ends the function. So what I'm doing is, if anytime someone calls in my dues, so let's say over here they set dues and they pass in a negative number, So now the school owes the student this much money. Well, it's not possible, right? I know you guys would love that, but it's not possible because the moment it reaches this line, it would return. Does that make sense? So this is a big reason we want to have set doozies, because inside the setter we could do some conditions. We could figure out if this is the correct thing to do with the number they give. We could do the same thing for age. When we set the age, if the age is negative, that doesn't make sense. If the age is 1000, that doesn't make sense either for humans, right? Everyone's following? So the getters and the setters, it's not always about just returning or setting it and then done. We could add some restrictions, some conditions, some functionality into it as well. And this is what encapsulation actually means, right? So even though we made the dues public in both cases, they have a purpose, a meaning, a usefulness for it to be set in here, for it to be public in here, right? Does everyone get this? And you had a question, Akshay? Okay. So the other thing you could also do is we have dues and it's always returning float, but let's say you had something else. Let's say you had a student heights, right? So again, it's gonna be private. We don't want anyone to change your height. And the height is gonna be in float because it could be point something. So let's say height and feet, right? Yeah, height and let's say meters actually. Okay, I'm really specifying. And usually people are, I think height in meters, I don't know. I really don't know meters or any of these numbers, so I'm just gonna say 5.0 foot. Okay, I should set it to 0 and then we set it, but for now let's just say everyone's height is in meters. This. I don't want people to change this, so what I'm gonna do is I'm gonna create a getter, and I don't want a setter. In this case, I don't want other people to change my height, right? And in this case, I could just say get my height, get height. Now, something else I could do, in this case, this is gonna return in meters, and we see that by the float, right? If the type was in float, we could do something else, which is overloading the same function, and rather than returning a float, we could return an int. Rather than returning what's going on? Yeah, it's because it's that. Rather than returning a float or an int, we could return in feet, right? We didn't define what a feet is, but we could have done that. And this is another thing we could do, even though it has 3 different names, because the return type is different, it could do some weird, funky stuff. So a good example would be if I wanted to get your height back in meters or in feet or in centimeters or in millimeters, we could create multiple getters, which gives you the different variations. Does that make sense? Actually, because I don't have feet and whatnot, let's just make this a bit cleaner. Maybe I'll do it like this. And again, this would be in, I don't know, feet, let's say. And this is fine too, and it's the same value, right? Get height and centimeters. And over here, the only thing I need to do is to do the formula to change meters into, let's say, feet. And to do that, I would go on Google, meter to feet. 3.28. So for each meter times this, what's giving me an error? Give me a double, so this is a F. And in centimeters, we do the same thing. Meters to centimeters. 100. So over here, we could say 100. And that's because this is, well, yeah, we could leave it as that. So now, even though I only have one variable that's containing my height, I actually have three different functionality that could return different stuff based on what I need, whoever calls this function. Any questions? No, that's good. If you have no more questions, I think we're gonna end it here. But I'll start. I'll need you guys to do your assignments. So I'm gonna set some assignments. So any questions? Last chance.
So, sir, what exactly I said was right or wrong?
I can't remember what you said anymore. The
Sir, like the private thing, yeah.
the
Like
like
it's
like I said, you were right about saying we need to privatize it and then we need to encapsulate it. The only problem that was wrong was you didn't understand why you were doing it. Does that make sense?
yeah, sir. That's exactly that we want like people to change it to the main function or some
Exactly.
other function.
We don't want outsiders to change it, but not always do we want to create these getters and setters. So like this final, we didn't need to create that extra layer, right? And sometimes we want to have an extra variation of the same thing. So in this height, we got meters, we got feet, and we got centimeters. Okay? Again, you weren't wrong. You just not having the correct answer or understanding why we're doing this, like all of this thing, is wrong. And the other, I think, if I remember correctly, you said we should always create the public, we should always create the functions for it. And this is not true. We shouldn't always create functions. So for some of these, like let's say sex and age, we don't want outsiders to get, or we don't want any functions to change it or vary it or whatever, right? So the
Okay, sir.
encapsulation is specific if we want outsiders to have access to it, or we want it in different formats, and this formula is done in just that one line.
Okay.
Okay. And again, sorry if I dissed your teacher. Eh,
No problem, sir. Sir, it was just doubt I want to clear out.
okay. Good. Any other questions? I should.
Sir,
Yes.
sir, in the what do we have to do in the aeroplane exercise? Like we have to